Welcome to our session today, where we're going to look at hypothesis testing. Hypothesis testing is a statistical method that we use to make decisions or draw conclusions about a population based on some data collected. So it will help us have evidence to support or to reject a claim. So hypothesis testing, these are simply claims about a population. A population is simply the entire group that we want to study. A sample is simply a subset of the population we are studying, and a parameter is simply a population measure, like the mean, standard deviation. So we had started by memorizing this song. We have the confidence level and the significance level. The two must add up to 100. So the common confidence levels we have is 99, 98, and can somebody help me with the last two? 95 and what?
90.
90. Then what are the levels of significance? 1%, the difference from 100, 2%, then 5%, then 10%. Are we together? This is called the significance level. Then we also looked at the alpha level. What is the alpha level? What are the alpha levels here? We just divide this by 100, 0.01. Then here, 0.02. Then here, 0.05. And finally, 0.10. And what is our Z?
Is it my network? Yes.
So our Z for a two-tailed test, this is 2.575.
575.
Then 2.33.
33.
Then 1.96
.96.
and 1.645.
645.
All right. So confidence level is simply the percentage that shows that you are confident, the degree of certainty, okay, about a sample. 99, 98, 95. So if your confidence level is 95, it means you're 95% confident that your true mean lies within your confidence interval. And we looked at how to calculate confidence interval. So the higher the confidence level, the more confident. But the wider the confidence interval. If you're 90%, you're less confident, meaning you're going to have a narrower confidence interval. So the significance level is simply the probability of rejecting the null hypothesis when it's actually true. It is also known as the risk of making the type 1 error. All right. So if a 5% significance level means you're willing to accept a 5% chance that yeah, you're willing to accept a 5% chance of being wrong when you actually reject the null hypothesis. So we also have the alpha level that you're seeing there. So 0.01, it means 10% risk level, 0.055% risk level. And these Z scores, sometimes we also have the T scores. If the sample is less than 30, they measure how many standard deviations of the sample are away from the mean. And Z is given by the X, the mean, minus the population, and standard deviation over square root of n. So we, if Z is greater than, Z calculated is greater than the critical value, these are critical values. Okay, critical values. If Z is greater than our critical value in there, it's just a two-tiered test. It means that you reject HO. If Z is less than the critical value there, it means we fail to reject HO. So some undergraduates will say you accept HO, but at postgraduate will say fail to reject HO. All right? Because we're accepting it doesn't mean we're sure. So HO is simply the assumption that we're going to have. And the critical values at 99 is 2.7575 or 576. At 98, that is 2.33. Please, I need you to memorize those ones. And at 95, 1.96, and 90, 1.645. So these things work together. Okay? You need to follow the steps. The steps in hypothesis testing, number one, you need to state the hypothesis. What hypothesis are we testing? The 5 steps. State the what? The hypothesis. Number two, we need to state the what? The level of significance. Number three, you need to calculate the Z. Number four, you need to make what decision? So these are the steps involved in hypothesis testing. It can be 5 or 4. State the hypothesis, then state the decision rule. State the level of significance and calculate the Z, then make a decision either to accept or reject our HO. So I don't want to complicate these things. When you are trying to test a hypothesis, you're trying to test differences. In the practical setup, you are confused and you want to understand the difference between um, a company that claims that the mean weight of a bag is 25 kgs. This is a hypothetical mean, it's a claim. But after you sampled 36 bags, you found actually that the mean weight, so this is statistical mean. Entire population, it was giving you're assuming that everything weighs what? 25 kgs. That's millimeter. But you actually did the sampling and the calculated mean from the sample, you found that it was what? It was 20 kgs with a standard deviation of 12. And they ask you, you test this at alpha 0.05. Test this whether these guys are stealing from us at alpha 0.05. So you need to calculate, follow the 5-step rule. So number one, state the hypothesis. So the assumed mean that they are claiming, their statement to say our mean is, these ones are weighing what? 25 kgs. That is what you put in the hypothesis. You can say, okay, these people claim that this bag of mini meal weighs 25 kgs. So you put mean is 25 kgs. Then that is the null hypothesis, the original hypothesis. And the alternative hypothesis is that maybe it's not equal to 25 actually. So we want to see whether we can sue them by testing the difference. We know there's a difference between 25 and 20, but we do not know how statistical it is. Then step 2, state the level of significance. Our level of significance is what? 5%. 2.05 is same as 5%. Okay, then you can make a decision from here. Our decision will be what? 5%, what is our Z at 5%? 1.9,
5% on
1.96, isn't it?
1.976. Yes.
So this will help you come up with the bell shape here. So you can illustrate it here. You put negative 1.96. And on the right side, you put a positive 1.96. So this is what gives you the criterion for rejecting or accepting HO. If you answer 4 in the shaded region, this is called the rejection region. The rejection region simply tells you that there's a significant difference in the mean and what they're claiming. So even in the other extreme here, this is the rejection region. So if you get your answer for the Z calculated falling in there, then just say, these people are lying to us. Then this is a fail to reject region. Others call it the accept region. So if your answer falls within this region, it means there's no difference at all. No difference, no significant difference in the mean. So you can't sue them. Okay, maybe it's machine error or what. But here, there's a significant difference. So there are problems when it falls here. All right. So step 3, we make a decision where we say reject what? HO. When do we reject HO? If Z calculated is greater than 1.96. Are we together so far? Then step
Yes.
4, you calculate the Z. What's the formula for the calculated Z? The X bar and the mu. What's the difference between X bar and the mu? The X bar has a sample size attached to it. Okay? So babies, it is claimed that babies weigh 3 kgs. After sampling 100 babies, we found that they are weighing 3.8 kgs. The 3.8 was calculated, it's called X bar. The 3 kgs is just a claim. So here it is claimed that when a bag of minimum weighs 25 kgs. After sampling the 6 kgs, we found that after sampling the 6 bags, we found that they weigh 20 kgs. So the 20 simply means what? It is calculated, it is X bar. So 20 minus 25, the standard deviation is 12. 12 over square root of n. N in this case is what? 36. 20 minus 25 is negative 5.
5.
Then 12 over 6 is 2.
So
Then our Z calculated will be negative 2.5.
5.
So you identify, someone tell me where is the 2.5? Is it in the rejection region or the accept region? Somewhere here, negative 2.5, right?
Yes.
So you reject HO if it's greater than 1.96 absolute. When you put absolute, whether it's this side or this side. Or if you want to be precise, we can say if z is greater than 1.96 or z is less than negative 1.96, because numbers on the left side are in the extreme. It's still okay, but just know that the mandatory value, the absolute value should be more than 1.96. So what is our conclusion here? You start with since our z calculated, which is 2.58, negative 2.5. Okay, it's in the rejection region, so it's less than negative 1.96. What's the conclusion? We reject HO. And what? So what? It means there's a significant difference. Okay, means there's a significant difference. So this is what we use when we're dealing with hypothesis testing, and this is all you need to know when you're dealing with that. Are we together?
Sure.
So I will want to give you a practical example, unless any questions. So this is when you're dealing with what? A sample. But when you're dealing with the population, z calculated is equal to what? The p hat, statistical mean, over the population divided by PQ over N squared. So sometimes you'll be given proportions. The same procedure, only part that you change is what? The Z calculated, the P calculated. So, for instance, it is believed that 30% watches at NBC. That's just a belief. Then you sample the population of 50 students, and you found that actually 50%, whatever has a bar is actually calculated. 50% watch what? ZNBC.
NBC.
And you're asked to test this at 99% confidence level. So we need to test whether there's a difference between what is claimed and what is actually on the ground. So similarly, you are going to follow a 5-step rule. Step one, test the hypothesis. So hypothesis in terms of proportion this time. So you say our actual hypothesis, our mean, and our alternative. Again, our alternative is HO, HA. Our hypothesis is HO.
One.
Alternative is H1 or HA. So you say proportion is what? 30% or 0.3. 0.3 watch ZNBC. Then yet maybe 0.3 don't watch ZNBC. So you can cancel out. That's step one, state the hypothesis. Step two, state the level of significance. At 99%, what is our level of significance? 1%, right? So you need to understand
Yes.
this one. 1%. So 1%, what is our Z at 1%?
2.575.
2.575. So this will guide you on coming up with a what? With a decision rule. So on the left side, you put 2.575, and on the right side, you put um, a negative. So this
Positive.
is um, negative on the left, positive on the right. Are you together so far? So if we
Sure.
calculate and we get 2.4, it is in the accept region. So we say, no, it's within range, so it's true. There's no significant difference. But if you get an answer outside, we say there's a statistical difference. All right, then step three, we calculate. Step four, we calculate. What is our Z calculated? The formula Z calculated would be what? For proportion, P hat minus P over PQ
PQ.
over N. So the Q is
Uh,
calculated from here. So our proportion, if it's 30%, what is the Q? 70%, right?
70%.
The remainder.
Yes.
The two must also add up to 100. If our proportion was 40%, the Q should have been what? 60%. You calculate the Q from
70.
the population proportion, not from this 50, the calculated one. Any questions so far?
I have a question on the 70, on the Q.
Mm-hmm. The Q,
Yeah, how did you get it?
how to calculate the Q is simply 1 minus P in short. Some books actually will show you P, then in brackets 1 minus P. It's a difference from 100. So if your proportion is 30%, your failure should be 70%. It's a difference from 100. So you use this population P. So P, if it was 10%, the remainder is 90%. Okay. So 0.5 minus 0.3 over 0.3 times 0.7
0.7.
over n, which is what? Can you quickly calculate that?
50.
What do we get?
And 3 times 0.7. Oh.
Quickly, what are you getting?
Good. Just write some.
Are the others calculating? Please participate in calculation. 0.5 minus 0.3 on top we have what? 0.2. Down 0.7 times 0.3. We get what? Divided by 0.7 times 0.3 divided by 50 is 0.004 square root. The answer we get 0.06. Okay. So what do we get as a final answer? 0.2 divided by 0.064. We get 3.1. Is it?
Yes.
3.125. So what do we conclude here? Pardon? When divide that, isn't the accept region or reject region?
Is
The 3. 3 is somewhere here on the number line. 3.1. So we reject.
checked.
So since our Z calculated 3.125. Is greater than what? 2.757. We reject HO. That's all. This carries 10 to 15 marks. You just need to know this principle. Any questions?
Just maybe your comment where you said anything with a bar, it is already calculated. Maybe if you can comment on that.
Okay. So just to differentiate, how do you know this one is our statistical? So X bar is got a sample size attached to it. Then there's a P bar, it has a sample size attached to it. Then mu is simply the assumption, and P is simply the assumption. So the question that arises sometimes is that how do we know which one is our mu, and how do we know which one is our X bar? Civil servants, it is believed that they get 10,000 per month. After doing a survey, we've actually found that from 64 people, they actually get 8,000 on average. So 10,000 simply is the mu. It has no sample size attached to it. It doesn't calculate it. Then the 8,000 is actually your X bar because you got this actually on the ground from the 64 people. Similarly, the proportion as well. All right. So those are the differences.
Yes.
I hope that is clear.
Okay. Yes, it is.
All right. So let's try to answer this question here together in applied perspective. So company claims its batteries.
Just a minute. Just a minute before you move. Also on the null hypothesis and the alternative,
Mhm.
you said if you reject the null hypothesis, what happens to the alternative?
It means you're accepting the alternative. Rejecting the null hypothesis means you're accepting the alternative hypothesis. So let's look at this. A company claims that its batteries last 500 hours on average. A sample of 36 shows the mean life is 490 with standard deviation 30 hours. Test the claim at 5% significance level. So set the hypothesis. What is our hypothesis in this case?
Switch.
So let's identify the things. Which one is our mu? Which one is our n? Which one is our x bar? And which one is our standard deviation? So this is our mu. Why?
What's the name?
It has no sample size attached. This one is our n. And what is this? It's the x bar. Why is this x bar? It was actually calculated from 36 batteries. And this one is obviously a standard deviation. So what is our um, hypothesis?
500 hours.
Mu is equal to 500 hours, correct? Then alternative hypothesis?
No, it is not equal to 500 hours.
Correct. Not equal to 500 hours. That's step one. Step two, what is our level of significance? 5%.
Give me 5%.
So meaning what is our Z?
That is 1.645, is it?
1.96.
966, sorry.
Standard. So meaning what is our decision rule? What is our decision rule? Reject HO if it's what? Else are not
Less
found.
than or greater than
Yes. Reject HO if what? If Z calculated is greater than
is
1.96 or Z calculated is less than what? Negative 1.96. Find together.
yes.
Then now we go to the what? I'm just showing you the steps just follow. So the hypothesis is just here. Okay, the test statistic is step 4. What's the formula for the Z?
X bar minus mu
X bar minus mu.
over square root of n.
What is our X bar?
Our X bar is 4. Is that 490? 490.
90 and our mu?
Mu is 500.
Okay. And what is our standard deviation?
It's 30 hours.
And our N?
Our N is 36 batteries.
36 batteries. Okay. What do you have on top? Negative 10.
Negative 10.
There's our standard error down there.
This is 30 divided by 6. This is 5.
And our final answer?
Negative 2. Negative 2.
Negative 2. So where's our negative 2? So this is our critical, our test statistic. So meaning Z calculated is what? Negative 2. Okay. And step 5, make a decision. What is our decision? Reject or fail to reject?
We reject because it's less than negative 1.96.
Okay. Is everyone on board? Are we together?